let's start with the SQL. What is SQL first? Let's start with what is SQL. SQL, some may call it, some people call it SQL, some call it SQL only. So whatever it, as per their compatibility, so we can say it SQL or SQL or anything. So basically it is it is short form of structured query language. Structured query, query language. Okay. Yes, just a minute. No, I am just admitting. Oh, sorry. Let's start. So SQL, some people call it as SQL or some may pronounce it as SQL. So both are fine. So what is SQL? SQL is a structured query language. Structured query language. And why SQL is required basically? Structured query language. So suppose we have data. So let's start from the what is data. Okay, data. We are focusing particularly on the data engineering and data science piece and data whatever data. So what we are, I will give the different different fields regarding this data. Okay, so let me take this as additional key pointer. So okay, what are the fields in data? Okay, so first one is data engineering. In, engineering, data engineering, and data engineering is a backbone of two streams. Basically it is backbone of two streams. It is data engineering feeds data to two streams basically, and these streams we can say like, mm, one is data science here, data science, here, and another piece is Power BI. So data analytics, data analytics. So what is difference between these three fields: data engineering, data analytics, and data science? This seems to be similar fields, right? Because each and every field has the data. So but these are not the same fields. I will tell you what is the basic difference between them. Let me take the shape for this. Okay. So data engineering, it is backbone of these two, data analytics and data science. What does the data engineers do? So the people who does the data engineering piece are called as data engineers, and the data analytics guys are called as they do particularly Power BI and SQL, so they are called data analytics. So their designation is also data analyst or something, data analyst. Okay, and then here we have data scientist. In the market currently, all these fields are in boom. Actually, if you see, there are huge requirement for data analysts also, huge requirement for data scientists also, and the data engineer is always at the, it is green field, evergreen field. So what, there are always opening for, always requirements for data engineer. And why this there are always requirements for these data engineers? Data engineers actually do the backbone of this data analyst and data scientist. So what I mean by backbone, suppose we have data here, data, and suppose maybe we have data in some Excel files. Okay, Excel files. Then we have some data in some text files. Then there are different types of files, suppose. And this data analyst, these guys want this data, Excel data. Then data science guys also want this excel data, this text file data. They have to do the analysis. Data scientists have to do the let's say future prediction. For the future prediction purpose they need data. But similarly we have a data analyst team. Data analyst team, why they need the data? So data analyst guys, they do the dashboards. Dashboard means there are like reports hosted. There are multiple reports hosted, and those reports they show to their management, so or the business. And for creating those dashboards and these reports, they also need the data. But who will get them this data? So there comes the data engineer role. Data engineer will, what he will do, this data analyst guy will the data analyst will say, give me this excel and a text file, and there are like n number of sources. Okay, give me this data in a particular tabular form so I can create dashboard out of it, right? But creating this data in particular, so there are like suppose three sources here, three sources, and they want, so segregation of these three sources, they want to make it together. So they will be able to showcase the whatever the data uh, we have. So similarly data science guys will suppose, let's take an example of Flipkart and orders. Okay, so how these use cases differ from domain to domain, I will explain you. Suppose there is one, there is orders data. Okay, orders data. So these data analytics guy, what they will do, they are just, the reports are created for, so reports are particularly created on the backdated data, backdated or backdated or current, maybe current data, or maybe 1 or 2 days back data. So backdated or current data, that is the where these reports are hosted. But data science guys, what they do, they will analyze this data, whatever the data we have, they will analyze and they will predict. Okay, they will predict. So you might have heard, so prediction is simple, like uh, you might, this Hawaman Khatas and all, the weather prediction, all this, they also do the same thing. They analyze the trend of data, whatever the trend happening or whatever that their parameters they consider, and from that they predict that there will be huge rain today or there won't be any rain today. So this comes under the prediction, and this piece is handled by data science guys. But these data analyst guys, they will just watch the previous data, what happened over the period of time. So they have previous data, they will analyze and they will tell, yes, in last 5 days this much rainfall occurred, in last 5 months this much rainfall occurred. So they are just calculating, doing the calculation based on the previous data or past data, or maybe current today's data, they might analyze. But usually we can take a reference of backdated data, because we need huge data for the analytics. For the similar purpose, they are also using the same data, but they are just predicting the future. They are just predicting the future. And all this data, suppose this is Flipkart data. This Flipkart, this data analytics guys, what they will do, they will calculate the trend of what orders. So suppose Flipkart has application in, suppose 500 countries. Okay, 100 countries are running the Flipkart application, but they will they will differentiate the data. They will differentiate the data for India, then they will differentiate the data for other, like n number of countries we have. So accordingly they will differentiate the data. Okay, but so this data is here with these guys. Suppose Flipkart captured like 1 million order for a day. Okay, 1 million order for a day, it's just a hypothetical number, assume this. The- they captured 1 million orders of data a day. But who will provide them this information? This data science guys also need this information. What are the 1 million orders, what are their order numbers? So this is important guys. So this is real time, real world scenario. So what are the like tables and how data is manipulated. So there are like n number of orders, one suppose 1 million of orders globally for the Flipkart, okay, or Amazon, whatever. So 1 million of orders, they every order has order ID, then username, who is username, and then his corresponding address, okay, then how he payment type, maybe payment type, right, then he address is already got. So just suppose we have five address type, okay, and then order status, maybe let's take order status. Orders, in order status, they must be tracking. So order, once you place the order, you get a notification that your order is placed. Then uh, the order is placed, then they will also drop you an email or message that your order is shipped. Then they will also drop an message that your order is nearby your hub. So shipment delivery hub, there are hubs where near facility, maybe for simple understanding, near facility. And then there is like out for delivery, okay, out for delivery. Then they will mark that particular order is delivered. And if you place the return order, then it falls under the collections. So collects in the inside, then again they will trigger that there is an order, your return order is accepted, and then there is a delivery boy, he will pick his order or something like that. Okay, just a sorry. So okay, suppose this is the only one order. See the how much huge amount of data is created. So for one order, suppose order ID was 1, for this one order, so it will track multiple stages. So for one order, this is the same order, this is the same order, this is same order, near this order came near facility, this order is delivered, this order is again came back, so they want to do it return. So the amount of data, suppose this is just a simple example, it's not like complicated, or I haven't kept this as a complicated one, just a simple example of how data is generated, okay. So for 1 million orders, suppose for one order we are getting 10 records. For particular one orders we are getting the 10 records. Then how will you store this information, right? So does anyone know how much information we can store in the Excel, in the particular sheet? What is the maximum limit? So if you can say directly, I will show you. Down. So we, so maximum, this as per my information, there are like 10 lakh rows, okay, and maximum columns are like 10,000. So what I mean to say, see these are the rows, 72, 73, 74, 75, these are the rows, and these are the columns. So this A, B, C, D, these are the columns. If you generate this huge amount of data, okay, so for one order we are generating 10 records. Just a simple example, 10 records we are generating. But how will you keep this data? Because for 1 million orders, suppose 1 million into 1 into will generate just a simple example of 10. It's not just a 10 rows, there are like huge number of rows generated for one order. But for simple understanding, just take 10 rows, and 1 million into 10, there will be 10 million records, 10 records per day. How you are going to deal with this 10 million of records, right? And along with these records, we have to track this elsewhere. So this order is shipped, this order is placed. So there are like tracking codes also. So if you can simply refer to the your Zomato guy. So once you place a particular order, right, you will be able to track on that Zomato app that this delivery boy is near the restaurant, he is coming near to the house. That's how every order is also tracked. So there comes another data like that is that comes under the streaming data. So continuous streaming is there. So that is another use case, streaming data. But for this, our what I may our purpose was how what these data engineers do. These data science guys also want the data for their prediction. These data analyst guys, these all guys also want the data for the creating dashboards. How many orders placed from India, or which region is getting lots of orders. So basically, they analyze the trends, which is the good region for us. And if you are not getting the business from that region, why you will spend lot of your employees? Suppose Flipkart, this is we have taken the Flipkart. So suppose there comes an rival application for this. There some time back we had the Snapdeal. No, Snapdeal used to create lots of revenue in India. So at that time Flipkart was not the trending application. So they will analyze. Oh, we are not getting any kind of orders in India. Why we have opened this? There are too many warehouses for this. So running and this logistic chain, there are like huge requirements in the PHP side. You just simply see the order coming and going, but there are like huge warehouses where your orders are kept. Then delivery guys, their charges. There are lots of parameters to be considered. But if you are not getting the revenue from suppose India, then what will they do in the India? So they will just simply shut down their operations in the India, and they will stay away to the another country where they are getting the business. So that is done under the data analytics part. And uh, future predict in the future prediction, in which is the piece of data science. What they will do, like they will analyze the trend over a period of time. So they will say, yeah, India is a huge country, and in the particular India, they will say, yeah, these rural people, Indian rural people, they don't order anything. So we don't want to create the hubs near rural areas. Just one hub for one district, that's enough. But for Pune, they will see, oh, Pune and Mumbai, these are huge hubs. They are getting like millions of orders for a day. So they will predict that there we must invest here. These are like high level decision. These are the management is taking. That's the purpose of this whole data. And as well as daily operational purpose. Also, suppose your order, you didn't get a proper order. So you raise the concern with this particular Flipkart team or something for tracking your order and doing all the necessary requirements. They will also need this data. So this data is required, and whatever the data, this huge 10 million of record what we generated for a day, no, they have to store somewhere. They have to store somewhere, and then they have to uh, retrieve this data whenever required. They have to retrieve, means get the data back. Get 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 the data, store the data, get the data, and then do analysis. Yes. Okay, so what is the role of data engineers here? So taking this huge amount of data, collecting daily huge amount of data, 10 million of records. We have to collect those 10 million of records, and we have to process these records. So process, what I mean to say, this is daily data, right? Daily data. But suppose if you generate this daily data, but you want to analyze the trends for data analytics piece as well as data science piece. They have to analyze the trend, they have to generate the reports. But they can't do just based on the one day of data, right? Suppose there are like 364 days in a year, but they will analyze the trend. Oh, weekends we get huge amount of orders. On the weekdays we normally get the lower orders, so we can take some relaxation to our employees or something. Okay, that's how they configure. And then what this 10 millions of records generated for a day. This is like transactional data, right? Transactional data. So day to day data is called as a transactional data. But whatever we collect over a period of time. Suppose this was generated for a day one, Then on another day we'll also get like to 15 million of records we may get. Then these are transactional data. Day to day data is kept kept in the databases. There comes the YSQL is needed. So day to day data is kept in the database. So database is just a repository or collection where all the data is kept, right? So now you might have got the understanding of what is the database. In simple words, we can say it is a organized collection of data stored, managed, so it can be easily accessed, updated, retrieved. I mean, we can get that data. So there comes the database. Okay, and yeah, so pretty well we covered this, what is database as well as what is the use of data engineer. So in order to process this data, in order to keep this data maintained, we have to keep this data tracked. So this is transactional data, and we have to manage and keep everyday's data. That is called as analytics. Analytics. Okay. This is transactional data, but this is analytical data, which in the simple terms we call as analytical. Analytic. Okay, so that are the like different roles in the our field, data field. And so in order to provide data to these data scientists as well as data analysts, we are there. So whenever there is the data, there are the data engineers. Because of this, data engineering becomes the backbone of this, because we are providing the data, we are the provider, we are the source makers. Whatever there are like like this is just a simple use case. This data is not as it is as it easy to store. There are like we have to perform the transformations. Transformation means we have to convert this data, we have to keep this data in the particular databases. For that, we have to take in the consideration what is the storage required, how this data can be kept. These are five to six columns, but in general there are like 300 and 400 columns in a table. So how they are managed, how they can relate to each other, that's how, that's where the data engineers come into play. They manipulate the data. So in simple terms, they do the ETL. ETL is equal to data engineering. So ETL is equal to data engineering. ETL means extract, transform, and load. That is our main goal. Extract, transform, and load. That is equal to data engineering. Earlier, this field was ETL. There was a field. They used to simply used to say as a ETL developer or ETL tester. These were the earlier roles. But over the period of time, you can see the how this field evolved. There came a huge number. There came the huge amount of data. So requirement for this data analytics guys and data scientists rapidly increased after the COVID period. So eventually the data engineering also rapidly evolved. So just earlier it was just ETL, now it is a huge department, data engineering. So what is this ETL? Extract, transform, and load equal to the data engineering. ETL is equal to the simply words data engineering. So extract, transform, and load simply. Let's take explore this. Extract, transform, and load. Extract means there are like, suppose there are uh, n number of odd sources, like 10 sources. There may be text files, then maybe Excel files, then there might be text file, Excel files, then we have the SQL server as a source, SQL files. Then there are like other data types also. JSON, I will take it later. So JSON is there, then XML is there. For some of folks, they won't understand the SQL, JSON, and XML, but simply understand these are the different file formats. Just we have text files, no, this we have Excel file, so we have SQL files as well, JSON files as well, XML files as well. So we will take these use cases ahead. But suppose you have like here, then application data is there. SAP SAP, you might have heard in your day-to-day activities, there is SAP data also. They, they they give us the data. So there are like 5 to 6 sources. Assume these 5 sources. We have to, what we will do, we will do the extraction of this data. We will do extraction of this data. Which one? Yes. So we will extract this data. Extract this data means just get this data from these different sources. These are our sources. We will extract this data, and then see, there are like different file formats. Suppose I will take one example. Okay, suppose here we have ID, just example, then name, then suppose he has its, just take from branch, and then ID name branch. Okay, address, maybe let's say address. Okay, so suppose there is one guy with ID 1. Let's assume her name is Pooja. Then she is from maybe civil branch. Okay, just a simple example, and her address is from, she is from Pune. Okay, so this is just a example of one file format. Simple, but some text files are there, so they will not keep put this data as a simple rows and columns. Here we have this one as a row, and this one as a ID is the column, name is the column. But there are some different sources which will simply keep like one, then Puja, then civil, and Pune. They are not worried about the how we will get to know the what is this data and what are these headers and everything. They don't care about it, so they will just keep everything in a one tab, and they will say, yeah, this is our kind of data, and this is simple text file. They will say comma separated text file. Okay, and then another comes, there are key value pair, like they will say like id is 1, and they will put inside some, maybe like in this uh, curly braces, and then they will say we have name as 1, name as Puja, then again they will keep it like branch as civil, and again address as Pune, and they will say we will give you this type of data. So yeah, we are not we won't care how you configure to store this data. And if you see, there are like different types of data, and they are not, they will simply push data to you and say, they will say we want to store this data, we want to store this data. So there are like 3 applications sending different kind of data, and this is just a simple data. And if you can see, relate to the data, this is the same data, ID, branch, civil, and address, Pune. This is same data, but how they are keeping, that is different. So we have to get the understanding how this data is, and then how we can extract this data, and then we have to transform. There comes the another layer, transform. And then third one is load. Okay, so here comes the transform. Here we will apply some transformations and we will load. We will load it. So here comes our, this becomes our source, right? This becomes our source, and this becomes our target. Load, we are doing load to the target. Okay, so that is the all we do as a data engineer. That's all we do. So but behind the scenes there are like huge logic, huge processes, huge changes, like huge amount of transformations means, oh, these are different files we have to store in SQL. Suppose SQL is our database, and how SQL is like this, structured query language we call it. SQL is keeps the data in this manner. It will keep like ID is one, name is Pooja, branch is civil, address is Pune. So this is the way SQL will keep the data. If you get another record like 2 is here, and then Vasu is here, and then branch is mechanical maybe, and then his address is from, let's say he is from Latur. Okay, so they will create another entry for another guy. Then there is third entry. Here is Utresh, and his branch is maybe again mechanical, and he is from, okay, he is from Solar. Okay, so this is how data is kept in the SQL. We call it as a simple database. So, but if you can see, this is not simple data. This is this is in key value pairs. So this is ID is key, and if one is value, name is key, and Puja is value, branch is civil. So this is a key value pair. But this is very this is comma separated file, and somewhere they will put there as a headers. But this is, again we have to convert this in this manner. So there comes our transformations. There comes our transformation. So transformation is the major layer in this. So this is the most important layer, because we have different sources, and we have to do the lots of convergence. Transformations means, in simple terms, assume it as a convergence. So we have to converge this data, so it will be compatible, to store in the SQL. That is all we are going to do in the SQL. So let's get back to the SQL again. So in order to, suppose we kept this data in the target, that is database. So we need to get this data, right? So everything you have done. So fetch the data from the source, converted that data, and kept somewhere in the target. But we need to extract that data. We need to use that data. How this data is kept in this manner? How will you get this data? It's not just a 3 records. If this there are 3 records, or 10 lakh of records, so that will be easy in the Excel. You will simply apply some filter here. In the Excel, how you do? You will here go, and you will apply some filter here, and you will just pull out like 100 or something. But that's not, it is good until there are like very minimal records, right? Even for 10 lakh of records, Excel will also get hanged. Excel will not able to provide the required result. So Excel will also get hang. If you try to open a huge file in the Excel, no, you might have encountered this issue. Huge, suppose 1 GB of file you try to export, open in the Excel will also get hang. But so this is huge amount of data. How we are going to get that data? There comes our SQL, structured query language. The structured query language is a language which is used to fetch the data stored in database. These are, there are like different types of databases, like relational and relational and non-relational means, suppose we have here, we have here what is uh, ID2, and ID2 is relating to Latur, right? If someone asks you what is the branch of Utresh, then how will you say? You will not go and check here is Utresh and here is the branch, but you will go to the Utresh. Here Utresh ID is ID3, Utresh branch is mechanical, and he is from Solapur. So how there is some relation between them, right? And suppose we have similar table. Suppose this is branch table name is branch table. But we have suppose another table where we are keeping is Suppose we are keeping id as a continuous continuous column in the both of the table. Suppose this is branch, but this is these are the is marks table. Okay, marks table. Suppose id they will define id is 1. Okay, and then is marks. Suppose here is another column, marks is marks, he got maybe 95%. Okay, but if you can see there is a relation between these two tables. This is marks table and this is branch table, but there is relation. If you want to relate this, how will you relate? There is one id column, right? Id column is similar in both of the tables, so we will simply relate to the id column, and they will get to know, yeah, id1 has 95%, but who is id1? You will not get it from this table, right? Who is id1? So in order to get that, where you will go? You will go, oh, id1 here. Id1 is Pooja got 95%. So that is means this data is related to each other. So this is called a relational database. In some maybe text files, suppose you create a text file, but it doesn't yesterday be created in Linux environment, so there was not any relation or correlation between them, right? So there comes the unstructured query language. There are like structured query language and unstructured query language. Unstructured, let's just focus on structured query language for now. Structured query language, in order SQL is used to fetch the data stored in the database, and then insert the data in database, then update the data. Suppose you entered here 95%, but you got to know that, that's not the correct percentage. She got maybe 94%, so we need to update that. Yes, yes. So we updated that record, and then if you want to insert another record, suppose there was another enter of Vasu, but this table has only this data. How will you enter this data into this table? So in order to enter the data, we use the SQL as a language. So basically SQL is structured query language used to fetch that use to fetch whatever the data stored in the database. We used to fetch using SQL. In order to insert the data into the SQL, update the data into the SQL, then in order to create the relation between two or three tables, we use the SQL. So SQL. So what they do, they will simply join these two tables. Suppose they will simply join the two tables, this table, branch table and marks table. They will simply join means they will make it in the such a manner that they will be able to like see like this. Yes, and then like this. So you are able to see the marks here also. So instead of going to this table, you will able to check the marks here itself. So we are joining this table based on this id. So joining the table, that is done with the help of SQL. So that's a quick background of SQL, because SQL is very important for us. Whatever the PySpark and other technologies, everything, everybody. So Power BI also we need the SQL. Python guys also need SQL. Everyone is must be very expert in the SQL, because this will cover the 60% of your interview, as well as your day-to-day activities will be. I will say not everyone will get to work on the other technologies, but everyone will get to work on this technology. Are you getting my point? So not everyone will get chance to work on Python maybe, but everyone has to work with SQL. If you are in the data, if you want to do some career in the data, you have no other option than the SQL. So this is your रोजी रोटी मान लो, या फिर तुम्हारा ये जो भी है, वो जो भी करना है वो SQL में ही करना है. So I think you might have got the pretty understanding of what is data engineering and why SQL is required. Okay. Okay, so that's the quick intro of SQL. But how is it getting worse, guys? Are you getting this? Yes, it is simple, right? It's not as tough as it is. I made it very simple. If you have any question, guys, just let me know so I can cover the next step, next thing. No question, guys. Was this much easy? Yeah. Okay. So if you uh, see this from AI point of view also, no. So we have these vector databases. So just to give you the point of view from the AI also. In AI also, how do you, some of you guys might not be might must not be knowing this how AI works. Okay, now AI is very trending. How AI works. Okay, let me summarize this how AI works. AI works. I will just simply AI works. So AI just suppose we have a chat GPT as a AI. Okay, chat GPT, GPT, chat GPT as AI. AI. What they will do? They will create a model. Chat GPT is suppose this is a simple model. They will they will get huge amount of data. Huge amount of data means what we discussed here was like just like very negligible amount of data. They will do they will do collect the huge amount of data means you can't even measure that data. So they will collect that data suppose for coding purpose. Coding purpose, suppose you are generating chat GPT for coding purpose, chat GPT as a AI for coding purpose. So whatever the information we have in the world for coding, they will collect, and that will be collected as a data, and they will train this chat GPT. This chat GPT, it's not chat GPT. Suppose this is a renamed letter, but it was a model. This was model. It was trained in such a way that all the exercises in the world, or all the odd use cases in the world for coding, it will thoroughly feed that data. Suppose all the queries of SQL, whatever the data we have in the world for SQL, that will be fed to this chat GPT, and based on that data, so based on these use cases, ChatGPT will come up with the something. Suppose if you ask him like what is the tablet I can take for the fever. So if we didn't feed as a data engineer, as if you didn't feed that data to the ChatGPT, he will be blank. That as a AI model, he will be blank. So in order to get that understanding to the ChatGPT, or that model, we have to feed the huge amount of data. Huge means you can't even imagine the how huge these data servers are, how these processors are. Even these processors are like, now companies are spending more on data engineering, data part. So there are like uh, huge amount of data centers coming, huge amount of data centers coming across the globe. So recently you might have heard that the Iran targeted AWS data centers in the Iran. AWS, they had their data centers in Iran. They targeted that data centers, and that affected a lot of AWS services. That's why data becomes very important. So if you have to train the AI, your AI model, we didn't cover this as a use cases here, use as a use case here, but in order to feed the data to the AI also, and to the model, to the particular model. In order to develop that model as a AI, we also need to feed the huge amount of data. So data engineer's role becomes critical from the AI point of view also. Yeah, data engineer's role is very critical. So that is these data science guys, they will train this model. That is another part, but the source still remains the same. We are the gatekeepers of that data. So data engineering becomes crucial. uh, yeah, so not a, so from the technological point of view, so we have, not everyone will get a chance to work on the Python, but everyone has to work with the SQL. So that is the importance of the SQL. And from AI point of view, there is also vector database. Some of you might have heard a vector database. This is also database. So the way it is keeping the data is, it is kind of, it is not a structured query language, it is NoSQL database. So this is SQL database, structured query language. But vector DB is not SQL database. We won't be able to, you won't be able to read this data in such a manner like what we used to read in here. So you will be able to, it is readable, right? If you query this data, get me the record where id is 3. So id is 3, then this will return with the this row only. So this is human readable, but there are some databases which are not human readable. So we need to, in order to make that data human readable, we have to convert that data. So in the AI also there is a database which is called like vector database. Okay, so this is NoSQL database, not structured query language we use here. NoSQL, we call it as a NoSQL database. There are two kind of databases, types of databases. Let me mark the types of DB. For database, we will simply mark the, denote it as a DB. Okay, moving onwards. So SQL database, SQL versus NoSQL. Okay, in the SQL databases, structured databases, we have this data in the this organized manner, row and column based manner. So we call this as a table. This is our one table. So this point is covered. So data is stored in the tabular manner. So that is table. That is one table. Okay. Let me say, let's say again. So there are two types of databases: structured database and no structured database. Let's take example of structured DB. We have SQL server. So there are like, suppose there is one, mobile, right? Mobile is uh, a utility, but that utility is provided by many of the users. There are like Vivo, which will provide the mobiles. Then we have Samsung who will provide the mobile. We have Apple who will provide the mobiles. Similarly, we have this SQL server which is from Microsoft. Most of the enterprise application use this application for the day-to-day data keeping and everything. So this SQL server, and then we have Oracle, from Oracle itself. So Oracle is there, and then we have DB2 from IBM. IBM will also have their own database. So these are like enterprise level databases which are used for keeping the data. So we will be installing this SQL server which is from Microsoft. This is enterprise application. We will use community edition of this, and we will try all the queries. And so this will be going to be the 1 month of exercise. So we will cover from basic to the top level. You will be able to write the queries from on your own. You will be able to do whatever I was talking this, right? You will be able to do this. And for this installation, there are some like NoSQL databases. No, let me come with this NoSQL DBs. NoSQL DBs, there are like MongoDB. So many of you might have heard this MongoDB, and then we have Cassandra, then Neo4j. Huh? Yes, DynamoDB is NoSQL. Yes, we are coming to the uh, cloud also. So just let me summarize this. So NoSQL DBs are Cassandra, MongoDB, Neo4j, Neo4j, and so these are like on premises. Like you understand, I will take this on premises and cloud when we are covering the cloud. So these are NoSQL databases, and here we have, there are like databases provided. Suppose this is our SQL Server database which is provided by Microsoft. We have some another like cloud providers. So we have major cloud providers as AWS, and then Azure, and then GCP. There are like Alibaba and all, lots of cloud service providers. We will just focus on top three. So AWS has its own database. They similar database, just a similar database. They will just rename it as a RDS. And then Azure, Azure database service, Azure database service for Azure. And then like for GCP, they have Cloud SQL, Cloud SQL. So and Azure is what is name of Azure? Azure RDS, I think. Azure SQL, maybe I don't exactly remember its name. Azure SQL. So see, underlying tech is same. Underlying technology is same. What is underlying technology? SQL we are going to run. You may even if it is SQL Server as your application, you are using Oracle as your application. If you are using DB2, if you are using RDS, you are using Azure, or you are using Cloud SQL. We have the underlying technology same, which is SQL. So that's why the importance of SQL is huge. So we will kick up tomorrow with the installation, and that is all for today, guys. I think we already reached to the 10. So apart from this